Okay, so we're asked to solve these simultaneous equations, and the way of doing this is we go downwards, and we're just going to circle this to show you. Now, with this, you've got to make sure that you have the coefficient of both of a letter, so the number before both a letter, the same. So we've got a 5 and a 5 here. Now you might argue that the second one's a -5 and you'd be right, but we're only interested in the number itself, not the sign before it. And then we've got to remember this simple rule. If you have the same sign, we subtract going downwards. If we have a different sign, we add going downwards. Okay, simple rule. But have a look here, the 5 and the -5 have different signs, so we're going to add going downwards. So we're going to do 7x plus 5x, which is 12x. Then we're going to do 5y plus -5y. Well, that ends up with nothing, and that's the whole point of this. If you end up with a y as well, this hasn't worked. And then 43 plus 5 is 48. And we'll put our lines going downwards. We're going to divide both sides by 12, so you've got x equals 4. Now that's only half of the question done, because we need to find out what y is, and you just need to pick an equation, and I generally pick the top one to feed that value of x into. So 7 times 4 plus 5y equals 43, and I've just copied the same question, or the same equation at the top, but I've put in the value of x as 4. So that's going to be 28 plus 5y equals 43. And then what we're going to do is we're going to take away 28 both sides. So take away 28, take away 28. So we end up with 5y on this side, and then on the other side we end up with 15. So we're going to divide 5 both sides. Y equals 3. Now if you've got some time, you can substitute that into the bottom equation and you'll find out that it actually works out.